Our first example using binomial distribution and a hypothesis test tells me that I have 40% support. So my null hypothesis is that the probability is 0.4. As I read through, they think the candidate is overestimating. So the alternative hypothesis is that actually the probability is less than 0.4. We're representing this as a binomial, and in our test we ask 20 people and we're going to test it against our probability of 0.4. In the test we discover that 3 people support. Because our alternative hypothesis is a less than, we're going to work out the value of the probability of x is less than or equal to 3. So doing this on the calculator, x is 3, n is 20, p is 0.4. I get a probability of 0.1596. We're going to compare this to 5%, as that's the significance value. Now 0.159 is greater than 0.05, so according to my sheet there is insufficient evidence to reject H0. Putting this in context, that means that the candidate is not overestimating, the candidate is right. Or at least we don't have evidence that the candidate is overestimating. Second example, very similar. So we're told probability is 0.1, so our H0 is that the probability is 0.1. Our alternative hypothesis, there's a suggestion there's been a reduction, so the probability is less than 0.1. We're testing this as a binomial with 100 articles against our probability of 0.1. In our test, we discovered 8 are faulty. Because our alternative hypothesis is less than, we're going to work out the probability of less than or equal to. Calculator tells me that x is 8, n is 100, p is 0.1. So the probability of this is 0.3208, and we're comparing it with 5% again. That's greater, so again we have insufficient evidence to reject H0. So in context, there has not been a reduction in the proportion of faulty articles. Third example, so our probability is 55%, so our H0, p equals 0.55. They think the support has reduced, so H1 probability is less than 0.55. It's been tested as a binomial distribution by asking 20 people, working on the assumption that the probability is 0.55. 7 people still support this candidate, less than in our alternative hypothesis, so less than or equal to in our test. So x is 7, n is 20, p is 0.55, is 0.05803. This time we want to test at the 2% significant level, so we're comparing it to 0.02. Again, it's greater than 0.02, so there is insufficient evidence to reject H0. So in context, the scandal hasn't damaged his popularity.